Recording. Okay, great. So we're recording the AP review group or study group on Wednesday, May 19th. And here we're discussing the AP exam that was given on May 4th of this year of 2021. We're going to cover 1, 2, and 3. Yesterday we did 4, 5, 6. 1 and 2 are specifically calculator required questions. Not that you need a calculator for all parts, but you definitely need some for some parts. So we'll do 1 and 2 for sure, and then 3 is non-calc. We'll go over that. I didn't do 3 yesterday, mainly because it deals with volume, and I haven't quite covered that with some students, but they are going to see it tomorrow, so I might as well do it today. So anyway, so here they have a data table. Apparently the first row deals with R, centimeters, maybe that's a radius, I guess, and F of R, some function that's milligrams per square centimeter, okay? So they say the density of bacteria population in a circular Petri dish, that explains why to use R, at a distance R centimeters from the center of the dish, so that's radius, of course, is given by an increase in differential function F, where F of R represents, again, milligrams per square centimeter. So you can see how that's density. Like if you have a certain amount of area and there's some weight or milligrams or mass associated with that area. Values of FR for selected values of R are given in the table above. Okay. So apparently, if you have nothing, or you're right at the center, then there's 1 milligram per square centimeter. And of course, if when the R gets bigger, the F of R gets bigger too, because it has a bigger density. Well, I don't say in course, but that's just how it looks like. So use the data in the table to estimate F prime of 2.25 using correct units in terms of the meaning of your answer in the context of this problem. So my guess is worth probably 2 points. Probably 1 point for estimating and 1 point for interpreting. Okay, so 2.25. We don't see 2.25 in the table, but we do see 2 and 2.5. So if you think about this graphically, what's going on here? When R is 2, F of R is 6, right? When R is 2.5, I'll put 2.5, kind of space it a little further away. The output is 10, of course, right? If I draw a curve, it's going to look, I don't know, maybe kind of like this. Or, I don't know, I'm just going to kind of just have a little fun with this. So let's say the curve looks like that. I don't know, something like that, right? Now, 2.25 will be over here. And we know that's supposed to be a tangent line, right? The derivative is always a tangent line. Well, what if I drew a secant line through R equals 2 and R equals 2.5? It's fair to say that the red and blue lines are totally parallel, but are kind of parallel. They're close enough. So the secant line could be a good estimate of F prime because I chose 2 endpoints that were symmetric about 2.25, right? 2 is 0.25 less than 2.25. 2.5 is 0.25 more than 2.25. So there we go, okay? So yeah. So we just do the secant line or average rate of change. So you just do F of 2.5 minus F of 2. And this is a very famous type of problem. They like ask this almost every year. So if you see it, that's what you do. Or if you see it in a multiple choice, do the same thing. So that's 10 minus 6 over 0.5. And by the way, if you want to leave your answer like that, that's totally fine. You can leave it just like that. You don't have to simplify it. But if you do simplify it, don't simplify it incorrectly because you not to get the point. You get 8. Now, if you put 8, you also don't get the point because they do want the units. You got to state the units also. The units are going to be, because you're dividing y by this, so it's actually going to be per cubic centimeter. So it's going to be 8 milligrams per cubic centimeter, because what you're doing is that you're doing milligrams per square centimeter over just centimeters straight up. Well, if you put centimeters as a fraction, centimeters over 1, and flip it, Well, I have milligrams per square centimeter times 1 over centimeters, which is milligrams per cubic centimeter. So there you go. Okay. Now interpret the meaning of this. So you would just say at R equals 2.25 centimeters, the density is increasing at a rate of 8 milligrams per cubic centimeter. Did I say what was changing? Absolutely, the density. Did I say where? Yeah, 2.25. Did I give the units? You bet. So really, it's 3 things. What, where, well, not what, where, why. That's actually more for relative mins and maxes. Really, it's more of the quantity, the units, and where it's happening. So quantity, yes, it's the density. Units, yep. Where? There. You gotta take care of those things. And of course, if you do know how it's exactly changing, of course, state that too. But all that is just worth just 1 point. So my guess is this was a 2-point problem. So question about A at all. Okay. Now I got you guys warmed up a little bit and you understand what's going on with the problem. I'm gonna give you a little bit of push for B and C and let you guys try it. And then we'll do D together. But let me give you a little push for B and C. Okay. For B, the total mass is given by the integral expression, fine. R times f of r dr from 0 to 4, which kind of makes sense because you start with 0 and end with 4. And 2 pi, wherever they got that, don't worry about it. What they want you to do is they want you to approximate the value of this integral using a right Riemann sum. So remember, if you're doing a right Riemann sum, you got the 2 pi still, but then the integral itself, let me get the highlighter out here. The integral itself is actually being approximated using a right Riemann sum, which I'm doing in the brackets. So yeah, you're gonna begin to evaluate this. But actually, before I get too carried away, because it is a little bit confusing, let's backtrack a little bit. You have R times f of R, okay. No, actually, I was right in doing this. Let me get you guys a kickstart here because it is a little confusing. So you're doing a right Riemann sum. So again, if you plot the points 0, 1, 1, 2, 2, 6, so it kind of has this like very sharp increase. Oh, I'm doing left Riemann sums, yikes. We're doing right Riemann sums. My apologies. There we go. We're doing right Riemann sums. So you're going to start with R equals 1. So you're going to put a 1 here because you have R. Times f of R. So you have to give the y value at 1, which is 2, and the width of the interval, which is 1 times 0. Sorry, 1 minus 0. So yeah, so we are using the right corner, which is at R equals 1, because this is the R axis, and that's f of R, of course. Plus, and then you keep going. So you have to then do the next interval. So you got to take that width and use R equals 2. So what I'm doing here, just so you know, this is R, this is f of r, and that was my first subinterval, the width. Okay, so the next one, as you imagine, would be 2 for r. The y value goes with this 6, and that distance is 2 minus 1. So it's a little tricky because they have that extra r there. That's kind of being a pest, but we have to deal with it. Then, of course, the next r is 2.5. That f of r is 10. And then 2.5 minus 2. And lastly, 4 times 18 and times 4 minus 2.5, okay. And by the way, you can leave your answer like that. Totally fine, but make sure you give the units, which is going to be just milligrams, because it says the total mass. So you can leave your answer like that. You don't actually have to simplify, you don't want to. If you do, then of course it's going to be 2 pi times 2 plus 12 plus 25, 12.5? Yeah, 12.5. 108. I think. Yeah, 108. And if you go a bit more, that's 14, 26.5, 134.5. Or to 69 pi. But again, you can kind of see, is it really worth our efforts? Not really. You have a calculator, I suppose. But you have to round 2 decimal places, but you could just leave your answer like that. That's totally okay. Now, will this be an over or underestimate? What do you guys think? You can put in the chat what you guys think. Given this an increasing function, because they said so, and the table shows it, and knowing what you know about Riemann sums, the way it's set up, yep, it's over. Very good. It's an overestimate, and your reasoning, because increasing function. That's all you gotta say. My guess is that's probably worth 1 point. Again, I think A is worth 2 points. I would say B is probably worth 3 points. Definitely, I think, or maybe it's worth 2 points. I don't know. Let's see what part D looks like, but that might be worth just 3 points. Or maybe part D is worth 2 points for reasoning, in addition to saying over. I don't know. Who knows? Then, if we take a look at D, the density of bacteria in the Petri dish is modeled by the following function, a really wacky function. For what value K, where K is between 1 and 4, is G of K, so you plug K into the G function, is equal to the average value, not average rate of change, average value of G of R. So remember, average value, in case you guys forgot, is just this. 1 over B minus A, or in our case, 1 over 4 minus 1, times the integral from 1 to 4 of our G of R function, okay? Our G of R function there. Okay. And you want that to equal to G of K. Or 2 minus 16 cos come on, let's get closer there. Closer, okay, 1.57. Root K. Okay, so you're going to have to use the calculator, and what I would suggest you do is you store this as y1. So let's do this together and see if we get the same answers. So I'm going to go to y1. I'm going to type in that function, 2 minus 16 cosine 1.57 root x parentheses, another parentheses, and cube. Actually, the cosine has to be cubed, so I need to put another parentheses there as well. So be very OCD with your parentheses, please. Okay. Now let's actually figure out the average value. 1/3 times. Now remember how to do this. You hit alpha, window, FN int. Alpha, window, FN int, 1 to 4. And then to call up the function, to call up y1, you have to hit alpha trace, in case you guys forgot. So after hit alpha window, I call up the integral. I go 1 to 4 for my lower upper limits. Then I got to do alpha trace y1, and then dx. And of course, I got to divide by 3, right? Because multiply by 1/3. So it's the integral itself was 29.627, and divide by 3, 9.876. Okay, so that's your average value. And you guys set this equal to this. Now, you can go about this algebraically, don't. Just use your calculator. So if you have 9.876 as average value and it equals the g of r function, or in this case, g of k, and remember, call this y1, I would just go back to your calculator and make 9.876 y2 like a horizontal line. I would just do that, 9.876, and just see where they touch. I mean, that's just going to be really your best bet there. Now, we do have to be a little more accurate. So what I'll probably do from an average value, let's store this as a letter in the calculator. Let's store, say, alpha. Let's store as like A. So to store, the store button is right above on, store, and you get alpha A. So it's a little more accurate. Then you go to Y2, you're going to say Y2 equals the letter A. So you hit alpha math, which is where A is located. And then I'd probably just graph maybe in the standard window if you hit zoom and then option 6 standard. And just looking for where they touch from 1 to 4. And actually, I might adjust the window a little bit. Maybe I'll make my Y max 20 so I can see it just a little better, you know. Okay, second, trace, intersect. Looks like it intersects twice. We went from 1 to 4. Okay, type in, if you were able to follow everything I just did, go and tell me what you get for K. You can go and type it in the chat. Or if you're lost, tell me you're lost. I'll explain it again. Definitely, this is definitely worth more, at least 3 points, just so you know. I'm guessing the average value. I think setting it up is probably worth 1 point. Getting the average value is worth another point. Getting the answer is at least a point. This is at least 3 points. I wouldn't be surprised if it's 4 points. Good. Thank you, Ellie. I got the same thing, 2.497. 2.497. Absolutely. And again, no need to actually solve for K algebraically because you already have it stored in Y1. Just graph it and then graph the average value. The average value we found using the calculator because we can't do this integral by hand. That's actually, I think it's impossible to do by hand. So yeah, that's what we do. Now be careful when you store Y2. If I did as 9.876, not as alpha A, would that have changed my answer? I don't know, curious. 9.876. So I got 2.497 for K. I guess K is a radius. I'm not sure if you have to really put units for that. I guess you could say centimeters. Probably wouldn't hurt to do that anyway, because it is a radius value. But if I did this again, intersect 1, 2, 3. Yeah, I still get 2.497 if I type 9.876. But if you did like 9.9, for example, if you rounded your average value a little too soon, and then tried graphing 9.9 instead of 9.876 or storing as alpha A, would that have altered our answer? 1, 2, 3. It would have. We would have had 2.450, or we have 2.500, 2.4999. So you could see why it's important to not round these things too soon and go into the process because you would lose a point for the answer. So certain respect we have to have for precision. Okay, so that covers number 1. And again, after we get off the call today, I would suggest you keep working through all the free response questions from the packets I shared with you guys. And we could do more of that on Friday. Friday, actually, I'm doing a mock exam for my D period students. And for those who are not in D period who like to do that, I will have that available to you guys as well. I'll put it up in Schoology. So look at number 2. So this is a linear motion one. So velocity of particle p is given by that function, great. And the intervals from 0 to pi. You're given an initial position, great. You have another particle that has its own function, great. And a same interval, 0 to pi, great. And initial position, great. Okay, so a lot of things are great here. Okay, good. We have a lot of information. It's very organized. I like it. So find the positions at t equals 1 for both of them. So my guess is you're going to have to, well, not my guess. You have to do 2 separate intervals. Obviously, you have to do that. So for the first one, you're going to integrate the velocity function, vpt dt, from 0 to pi. And that's going to equal your position. I like to use s. For some people use x for position. I'll use s. That's going to be s pi minus s0. So I guess you get a point for that setup and then a point for solving for s0. Sorry, s pi. S pi is going to be S0, which I know is 5, plus that integral, which I need to work on the calculator. And then you can do likewise over here. 0 to pi for VQ, okay, VQ t dt equals S pi minus S0. And S0 is 10 here. Plus that integral. Okay, I'm going to let you guys work those out. So store, and you may want to right off the bat, store this as Y1, because you're probably going to have to use it later on, and store that the VQ form as Y2. You may just want to do that right off the bat. And also make sure you're in radian mode, very important, because you will get a wrong answer for VP at least, because that involves trig. Wouldn't matter for VQ, there's no trig there, but it would matter for VP. So yeah, I would gather they'll give you a point for each of the setups and a point for each. So it's probably worth 4 points, maybe, I don't know. Who knows how to design the points, but you know, I think it's a little cruel that they're asking you to do 2 different problems in the one part, but whatever. So go ahead and tell me what you guys get. I'm gonna do the same. I'm gonna plug these in myself. We'll see if we get the same thing. And there are no units here, so don't worry about it.
Why do you have pi as the upper limit instead of 1 if we're trying to find?
Oh my God, you are so correct. I am so wrong. Oh, goodness. Yeah, I don't know, because I want to do pi. Okay, so let's backtrack a little bit. So hopefully those who are watching this video will realize that. But good, at least I'm going to correct myself. It's an easy fix. So we just do this. Okay, let's make that 1. Okie dokie. Take 2. Alpha trace 0 to 1. Alpha trace y1 dx. Okay, so I get 0.3771. So it's 5.371. And then if I do it again for y2, I get negative 1.436. Ten plus that number is 8.564. Okay. Are we okay now? We're good? All right. Now we know the positions. Now we need to know, are they moving towards each other or away from each other? So what you need to do is, so you can kind of think of like a number line, right? Like let's just, or coordinate plane. So P is right here, Q is right here, right? Because Q is to the right of P, because Q has a further position. Let's consider what the velocities are at those moments. What is the velocity of each of those at 1? So the beauty about storing these right from the get-go is that now all you have to do, so we do need the velocity here. So what's VP of 1? So all you have to do is hit alpha trace. And just put y1 and then parentheses 1. That'll get us that. So alpha trace y1 parentheses 1. I get 0.84. So it's moving to the right. 0.841. So it's moving to the right. Now what's happening to Q? Is that moving to the right or moving to the left? My guess is probably going to be moving to the left because they want it to go towards each other. But just to be sure, oh, that came out nice. Actually, it came out really nice. Okay, the velocity here is -1. So they're moving toward each other. And explain your reasoning. You could just say, hey, velocity of P is 5.371, velocity of Q is 8.564 from part A. So Q is to the right of P. However, P is moving to the right, given a positive velocity. Q is moving to the left, given its negative velocity. Hence, they're going toward each other. Yeah, I would guess that would be worth at least a couple of points because you're using the positions and then you're using the velocities to make your statement. Okay, find acceleration. And they just want for Q, okay. And then they're asking you, is it increasing or decreasing? So I'm guessing it's also worth probably 2 points. Okay, I'm going to clear my drawings. Acceleration is going to be velocity. So you need to do VQT prime, or actually, just plug in 1 straight up. So you can do that in the calculator. Remember, you go alpha window again. So hit alpha window and deriv d dx and alpha trace y1. This now you see the importance of storing this right from the beginning. You do not want to type this over and over again. So it's going to take too long. And what if you punch it in incorrectly? You save a lot of time. So 0.810 I get for my acceleration. So that's easy. That's probably worth the point. And then for speed, we're speeding up or increasing speed when velocity and acceleration are both positive or negative. You're slowing down when velocity is positive, acceleration is negative, or velocity is negative, acceleration is positive, because then the acceleration is working against you, right? Well, our velocity for Q, we knew from part B was negative, right? We knew VQ of 1 was -1. But our acceleration is 0.810, so they're working against each other. Because you're going to the left, the acceleration is positive, so you're definitely going to be slowing down.
Mr. E,
Yeah, go ahead.
could you go over one more time how, like on the calculator, you found the derivative of V and then plugged in 1? Because I thought I did it right, but I got a different answer. So I was wondering what I did wrong.
Oh, you know what? I made a mistake again. You guys are on it today. I accidentally did Y1. I'm supposed to do Y2.
Okay.
Yeah. No, you're fine. So so take 2. All right. I think I just need to That's what it is. I'm just tired.
I got
1.0. Yeah.
Yeah.
Actually, I would still get the point for the second part. I got lucky there. Yeah, 1.027. Yeah, there we go. Okay. Still, the second part's right. And the reason is correct. Okay. Finally, total distance. Let's see if I actually can do this right the first time. It's total, not net. It's not displacement. Displacement, you just do an integral strip. Total distance, you're going to be integrating the velocity, and you do this from 0 to pi. So now I definitely use pi. And you do the absolute value of the velocity. And this is for P, not for Q. So for P, so I guess it's 1 point for the setup and 1 point for the answer. So trying to figure out which one of these would have to make worth 3 points. Yeah, probably A as my guess. That's probably worth 3 points, maybe 1 point for all. Combined for the sets, 1 point for each of the answers, maybe. And then B's worth 2 points, C's worth 2 points, and D's worth 2 points. Yeah, I'm guessing that's how they probably divide the points. So you just work that out. Let's see if we get the same answer. I'm going to do it myself. Go and type in the chat once you get it. And it's just Y1, that's right for VP. It's absolute value, mind you. Don't forget the absolute value. Takes a while. I have the same thing. Very good. I got 1.931. Yeah, thank you, Ellie. I got 1.931. Great. Awesome. Good work. Now, if they were to ask for the speed, or the average speed, sometimes they, you might see that. So it's going to be or the average velocity. If you're doing average value, you always do 1 over B minus A. And then you integrate your function itself. But if it's speed, because the absolute value of velocity is speed, so you would do this. It's pretty much the same thing, but you have this extra thing here because you're dividing by a time interval to get it as a speed value. So just so you know, if it's speed, if they say average speed, you have to do that. If it's just average velocity, then you don't have the absolute values. And because it's an average value, that's why you do 1 over B minus A. Just so you know, if they ask that question, which it could. We did, I think, in our final exam back in the day. Okay, so we've got great timing here. We're going to go do one more problem. Okay, so I did cover this with my D period yesterday, but I'm going to do it again anyway. And then I'm going to talk about B and C because those are kind of funky ones. So let me walk you through the set for part A. So they want the area in the region in the first quadrant bound by the x-axis in that graph, and they do say C is 6. And apparently this is the general kind of graph for this function y equals cx root 4 minus x squared. One thing you'll need to do is figure out where they intersect, or where the x-intercepts are. I do know that this is 0. This right here is going to be 2. The reason why is that if I were to set y equal to 0, obviously cx could equal 0, or root 4 minus x squared could equal 0. If root 4 minus x squared equals 0, then 4 minus x squared is 0. X squared is 4. X is plus or minus 2. So negative 2 would also be another possibility. My guess is the curve does something kind of like this. But I don't care about the left, the left of the y-axis or the other quadrant. So that would be 2. And so I'm guessing that's probably 1. So if I want to find the area, you're just integrating from 0 to 2. And this is without a calculator. This is non-calc now. C is 6 is 6 times x times root 4 minus x squared dx. You could probably push the 6 off to the side. And you're probably going to want to do a u sub. Not probably, I know you're going to do a u sub. So I'm going to let you guys do it. I know I did it yesterday in class for my D period students, but give a little push here in du over dx. You guys should know it's negative 2x. So you have to do a substitution, and then you'll have to go through the process, and you do have to change the limits of integration as well. You will have to change both the 0 and the 2 to have in terms of u. I'm just going to grab a glass of water from the kitchen. Why don't you guys try that? We'll see if we get the same answer. And then B and C, those are going to be fun ones. We'll wrap up with those. Okay. So let's see if it's the same thing. Du equals negative 2x dx. Dx is du over negative 2x. Your integral. Let me do that. Is going to be 6. You do have to change the limits of integration, by the way. So when x is 0, u is going to be 4 when you plug into the u equals 4 minus x squared relationship. When x is 2, u is going to be 0. So that must change. X times root u times du over negative 2x. The x's will cancel, as they should. 6 over negative 2 is negative 3, so you got negative 3. Integral from 4 to 0, root u du. Now, if you integrate that correctly, you should get, that's u to the 1/2, right? Add 1 to the exponent, divide by a new exponent. U to the 3/2, divided by 3/2, negative 3 being multiplied to it. We go from 4 to 0. Okay, there's a lot of stuff going here, so I'm going to erase those things. Flip over the 2/3. That comes negative 2. Yeah. And plug in 4 to the 3/2 minus 0 to the 3/2. Square of 4 is 2. 2 cubed is 8. So we should get, hold on a sec. Here should be positive. What I did wrong. Oh, you gotta put 0 first and 4. My bad.
I just have a question. So if you decide to do the u sub and then you change the limits of integration, then you don't substitute the like 4 minus x squared back into the equation.
Right.
But if you don't change the limits of integration, then
you still have to change it because incorrect not to when you have u involved. But if you want, you can go back So after once you're at this part over here,
Yeah.
if you so desire, you can, so you have -2, -3 times 2/3, then you can replace u back with 4 minus x squared. And of course, it's raised to 3/2 power. And then put back in 0 and 2.
Okay.
You can do that if you want.
Okay.
But as an intermediate step, you have to show that change. And I'm guessing they're going to dock you if you don't. In fact, actually, Mrs. Blanford has taught this course. She's retired now. She's going to be grading again this year. And I know her very well. And she will dock you if you don't do that. So even their teachers who are retired are still going to be grading. And so they're full sticklers. So my suggestion, no need to go back to X. Definitely this is a behemoth of a problem. So my guess is doing the set was probably worth 1 point. Doing the use of is probably worth another point. The process integration itself is probably worth another point. The answer, probably gas is probably worth at least probably 4 points. I don't know. I do think this one's a bit cruel because right out of the gates, you've been testing for over 2 hours now, and they give you this. And by the way, feel free to skip around. Wait 1 sec. You can't if you're digital. Yeah, unfortunately, won't be able to skip around. So you'll have to make a decision. This is taking too long because you get 15 minutes per response. So yeah, I think for response, I don't think you can skip around. I think you have to do the problems as they arrive. For part B, but if we could do it next week on paper, then yes, you can skip around. So I would suggest you do that. Okay, now part B, this is the fun one. This is where the fun begins.
I have to leave, Mr. E, but thank you.
Oh, no problem. Okay. Okay. So volume. That's what's happening here. It is known that blah, fine. The derivative is that. For approximate the radius of the largest. Okay, actually, it's not a volume problem just yet. I think that's for part C. The radius of the large cross-sectional area of circular size 1.2 inches. So what's happening is that the large cross-sectional circular slice was the value of well, first off, that's going to happen over here. So we haven't started rotating this yet, but oh, actually, never mind. It is rotating. Never mind. They do say that. It's rotating about the x-axis. Here we go. So you're going to have this region kind of like this here. Kind of looks like a whale or fish, but anyway. So if you're rotating this around the x-axis, you can generate the solid, and the large circle cross section will be wherever we see this peak. So it's going to be at the horizontal tangent, right? So a horizontal tangent here. And apparently they say that the radius is 1.2. So I know the y value here is 1.2. I don't know what the x value is there just yet. But they want you to solve for it. So 1.2 will equal c times x times root 4 minus x squared. Okay, I have a problem because I need to solve for c, and I don't know what x is. But they do give me a derivative here, which is very helpful. And the thing is that I do know the derivative is going to be 0 at that location because you have a horizontal tangent. So I'm going to replace dy over dx with 0. When a fraction equals 0, the numerator equals 0. So 0 equals that. Well, of course, it's not going to be 0 because then you wouldn't have a function. Just be a horizontal, it'd be like the x-axis. So 4 minus 2x squared must be 0. Okay. 4 equals 2x squared. Okay. X squared equals 2. Okay. X is root 2. Okay. We're okay now. And it's plus or minus. My guess is, yeah, the curve does something like this on the other side, but I don't care about that. So root 2 comma 1.2 is where that happens. Awesome. Now I could solve for c. So to solve for c, again, I just thought this was kind of cruel. There's a lot of math you have to do here. 1.2 c times root 2. It's not hard, just pain in the ass, really, more than anything else. And then you got to square the root 2, because if you do root 2 squared, that's just 2 straight up. So you have c times root 2, or it's just c times 2. So c is 0.6. Yeah, c is 0.6. That's kind of crazy, right? C is 0.6. Okay, well, that's what I got for c. Finally, for another spinning toy, the volume is 2 pi. What is the value of c for the spinning toy? Okay. So that's toy volume revolution. So what you're going to do is volume's always going to be pi. This is a disk method, by the way. So you have these thin disks going from A to B or from 0 to 2. And we're interested in knowing the radius. The radius is going to be strictly determined by the y value. And the y value is determined by this equation, cx root 4 minus x squared. So I'll need to square my radius, because it's pi r squared times the thickness of each disk, which is dx. So my volume will be pi 0 to 2. And I'm squaring. So cx times root 4 minus x squared dx. Now, usually they just ask you just give the setup. In fact, they want you to go through with this. It sucks. I don't like it. But volume's 2 pi. You have pi here. Just square that, it becomes c squared x squared times 4 minus x squared. Dx. Pi's will cancel. And then you could actually pull out the c squared to the left of the integral. So 2 equals c squared. Integral from 0 to 2. And then I'm going to shift the x squared. So I got 4x squared minus x to the 4 dx. And then I have to go through the integration of that. That's going to be 4x cubed over 3 minus x5 over 5 from 0 to 2. And remember, you still have a c squared being multiplied all that junk. And you still got 2 on the left side. Don't forget about that. If you plug in 2, I think you get 4 times a. So you get 32 over 3 minus 32 over 5. And of course, you get 0 minus 0. You plug in 0. Again, multiply to c squared equals 2. Find the LCD. Goodness. I would really like to talk to the person who wrote this from, like, dude, are you serious? You actually are making the kids do this? So it's 160 over 15 minus 96 over 15. Yeah, 96 over 15. 64 out of 15. Again, c squared equals 2. Multiply both sides by 15 over 64, so you get 30 over 64 equals c squared. Square both sides, get root 30 over 8. My goodness. That's what c would equal. I don't know how you divide up these points. Just given all the work you have to do. I mean, I feel A was at least worth 3 points, and B, maybe they probably did 3 points for each of them, but I feel each one should be worth 4 points. I don't know. That's a behemoth of a problem. Just, you know, John and Billy, 4, 5, 6 are much easier. So, okay. So I think that concludes it. We're a little bit past 10 o'clock. So I'll show this recording. I won't be available tomorrow, but Ms. Sinivak will be. And then Friday I'll be available again. I think we'll just do, maybe I'll just pick some random problems from the AP review stuff, or see if you have questions. And then I know the weekend's gonna be busy with graduation type stuff and other things. So, but I don't think that will be, definitely not too huge on, and that you both, so it actually won't matter to you if you guys are juniors. So I'll probably also try to be available on Sunday as well. I'm gonna see if I can move my schedule around a little bit, but I'm gonna have kind of a drop-in thing on Sunday, just the day before the AP exam. Probably around 1 o'clock is my guess. Well, I might just do 12:30 to 2. Maybe I'll do something like that. So, okay. Well, I think we're all set. And I'll see you guys later.
Thank you.
Goodbye.